Welcome to this lecture, and we said we are going to be looking at IP addressing and subnetting, right? So previously we looked at what IP addressing is, and we're also going to understand what subnetting is. So in the previous lecture, just like what Thomas contributed, for those who are not around, we looked at what an address is, and we said it is a unique number or a unique number ID assigned to one host or to an interface in a network. And when we say subnet, we are basically looking at a subnetwork, and we are saying it is a portion of that network that shares a particular subnet address. And we are going to look at what the subnet address is, or what we call the subnet mask. And we are saying, just like our IP address, which we said it is 32 bits long, we are saying that it's also a 32-bit combination used to describe which portion of an address refers to the subnet and which part refers to the host. So its main task is for us, or aim is for us to be able to distinguish between our network bits and our host bits. And that is a use of our subnet mask. We also looked at what an interface is, and we said it's a network connection, whereas an IP address is an address which is used to uniquely identify any node on our network. Just a brief refresher, we said that IP, it is a protocol which is part of the TCP/IP protocol stack or suite, which is used so widely today. And we are also saying it is also part of the OSI model, which has 7 layers, which are used to help us in structuring our network. So IP address is used at what layer?
At layer 3.
At layer 3. And as we are using the IP address, which data unit is being transferred via layer 3 from one device to another. Remember, we said when it comes to the data link layer, we are basically looking at what we call the frame, right? Isn't it? And when we go to the transport layer, we are looking at what we call a segment, isn't it? So which data unit are we looking at when we go to layer 3?
Packets.
Packets.
We're looking at packets. So you'll be hearing a lot of packets here and there. So we looked at IP addressing, and this is just a typical example of how an IP address looks like. So we have this one, which has a combination of both the network bit and the host bit. So this being our network bit, which is 192.168.1, and then finally the host bit, which is .1. This IP belongs to what class?
Class C.
It belongs to class C of our IP address. And when you're looking at class C, we said class C has how many network bits?
It has 24.
It has 24 network bits. And how many host bits?
8 host bits.
8 host bits, isn't it? So we looked at different classes. For those who are not around and you don't know how we're able to do this conversion and convert our IP address into the binary, I would kindly refer that you go ahead and look at some of those things in detail so that you can understand how we are able to convert this number, these numbers into binary. So I was just briefly going through these things so that you are able to know what these things are and what they do, and also to refresh your mind on some of those things that we looked at in the previous lecture. So we said in any network, in any IP network, we have 2 reserved IP addresses, one being the network address and the other one being the broadcast address. These addresses cannot be assigned to hosts on our network, and ideally they are not part of the valid IP addresses which can be assigned to our hosts. So we have the network address and the broadcast address on every network, and we shall come to appreciate that later on when we go to subnetting. So we looked at how do we convert from binary to decimal and vice versa, and I'm going very fast because we already looked at these things. So I assume by now everyone in this class should be in position to go ahead and convert our IP address into binary as need arises. So we looked at binary conversion, but also we went ahead and looked at what we call IP addresses. we have IP addresses that range from class A, and we said class A ranges from 1.0.0.0 to 126.255.255.255, and that is class A. And when it comes to class A, it has 8 network bits and 24 host bits. So when it comes to class B has 16 bits and it has also 16 host bits. And class C also has 24 network bits and 8 bits. Now, it is important for you to have this knowledge at the back of your mind, because when you have this knowledge, it will make it easier for you when it comes to subnetting, more so when you're doing class 4 subnetting. Now, we are going to look at 2 kinds of subnetting. What we are going to call the classless subnetting, or the variable length, and we are going to first look at the fixed length subnetting. So we also have class D, and we also have class E. We said these ones, we're not going to focus at these classes because they are not in the scope of this course. They're used for some different things. But for now, we're going to focus at class A, class B, and class C. So please take note of the ranges of the IP addresses, all right? And then we shall see how best we can move forward later on. So we said we also have types. So we had classification before, and now we have what we call types. Still, we have what we call private addresses and also public addresses. The public addresses may not be listed here, but like I told you earlier on, for you to be able to access the internet, you need to have what they call a public IP address. And a public IP address is only assigned by an organization called ICANN, or which of course these are service providers like Airtel, like MTN, and etc. Go ahead and also buy them from them, and then you're also able to get them. And any organization requires to buy a few public IP addresses so they are able to access the internet. Now, because addresses are not enough, the other time we looked at the people who are online at that particular moment, there are about 5 billion people, right? And we know that the number of IP addresses are not enough to take care of all those devices. That's why now all organizations can have what we call private addresses. And in case these computers or nodes need to access the internet, they may need to do what we call the NAT, the network address translation. And we shall look at this concept later on. But for now, we are looking at what we are calling private address ranges, which are addresses which you can privately assign to your local area network within your organization, within your home, or the different buildings that you may need to network. So still under the private addresses range, they are also following our previous classification, where we have class A, and it ranges from this range to this range. We have class B, which ranges from 172.16. And if you're aware, if you go to any computer connected on the MOBS network, it will have this IP address of 172.16. So meaning MOBS is using class B of the private address ranges. All right. I hope we are together with that. And then finally, class C, which ranges from 192.168. If you checked your computer at this particular moment, you will be able to see that your computer is using this range, right? Most of the times by default, our personal computers use that range. So if I come here on my settings and I go ahead and look for the settings, right? Let me just look for settings, and I open my settings just real quick. You can all see my settings?
Yes, we can.
All right, so if I come here to network and internet, and I come here to check on my network connections or settings, and I come here and click on show properties, I think, because I want to see my IP address, you will come to realize that these are my details here. My IP address is 192.168.0.100. Are we together, guys? This is the IP address which has been assigned my computer by my home router. So this is my IP address, and it falls in which class?
Class C.
It falls in class C, and it's also a private IP address. I hope we are together. So like I said, we have two types of IP addressing. We have IP version 4 and IP version 6. Now version 6 came in to try and solve the problem of shortage, because people got worried. The network engineers then got worried that we may deplete all the IP addresses and we may have a problem of shortage of IP addresses. That's why they decided to come up with a different type of IP version 6 to make sure that it can take care of the shortage. It has more IP address ranges as compared to IP version 4. But the way these two are implemented is totally different. And our network infrastructure today is built on IP version 4. That's why it is still running, and I can assure you it is going to run for as many years to come as possible. So it is still very valid and people are still using it because of some of its robustness and the advantages that it has. So we also have what we call special addresses, one of them being diagnostic addresses, and its range comes from 127.0.0.0 and to 127.255.255.255. Now this address is most of the times used by interfaces or used by devices to be what they call a loopback device, or what we could call actually the local host address, right? The local host IP address, or what we call the loopback IP address. Now, we may not focus on what the loopback does, but there's some concept which actually helps you understand what a loopback IP address is. Now, when you come to an address, which sometimes we call this one as well broadcast, because it is used to mean any network. The moment you see .0.0.0, actually, it means that we are sending to any network. We don't know the network, so this is a representation of any network. And the network broadcast IP address, we said all the ones, all the bits in our 4 octaves are turned on into ones. That's why we are ending up with 255.255.255.255. Now, all this was part of the last lecture, and I did not really intend to focus so much on that, but I just wanted to give you a recap of what we looked at so that when we start subnetting, you get an idea and try to understand what we want to achieve at the end of the day. So we had an illustration here of host A and host B. All right, so we have host C and host D. So if at all, this particular computer here, right? Quick question now, guys, for those who are attentive. If host A wants to send a packet, to send information to computer B, right? And we only have a switch in between here, right? A switch, layer 2 switch. Do you think host A will successfully send its packet to host B?
No.
All right, Diana, thank you. Why do you think so? You are correct, by the way. Why do you think so? It will not be able to send the data information much as the cables are connected, they're all on, the switch is on. Why do you think so?
Let me try.
Okay.
Because there is no route. There's no
Okay.
route that is connected to the switch.
Okay. That is also true. It doesn't bring out the actual communication, but let me also just ask another question very well. You all know, before even we dig deeper, that all these addresses belong to class C, right? They belong to class C, right? And that means that the network address ranges all the way up to these 24 bits, isn't it? The network address ranges up to this 24 bits. By 24 bits, I mean the first 3 octaves, they are all 8s, right? And they are all 1s. Are we together, guys? So this is our network addresses, right? So to back up what Diana has said, IP address 192.168.1 belongs to the same network with host C, right? Because they have the same network address ideally. Because remember, the last one is the host address. Are we together, guys? So that means that host B and host D are on the same network. Now, when we are looking at the OSI model, we said that the switch is only used to move data frames from one computer to another only if they're on the same network domain, all in the same network. Are we together? So meaning the purpose of the router now is to help us route using the default gateway, that if we get packets from host A, and host A clearly is on the different network right now, right? If we get packets from host A and we want them to send them to host B, which is also on a different network, we have a network of 192.168.1.0, and we have another network of 192.168.2.0. These are network addresses, and we can see how we are going to arrive at these addresses. But these are network addresses, meaning we have two different networks. And as you can see, host A here and host B belong to different networks. So if we need to determine the route and path which is going to help us send these packets to this computer, we need a layer 3 device. And in this case, a router, which makes Diana's submission 100% correct. But if we wanted to only send from host B, which is .network 2, to host C, which is to host D, which is also .2, even if we just have a switch, our information will reach our computer successfully. I also thought that it is important that I go ahead and mention those things. So as you see here, we have two networks. We have network 1 and network 2. We have two networks. And we said with class C, it has 24 bits. So all these bits are turned on into 1. All these 8 bits, right? They're turned on into 1. And then the host bits now are zeros. If we convert this number to binary using a subnet mask. So when we last met, we had introduced ourselves to what we call the network masks, right? Or what we call the default subnet mask. And we are saying, and please pay attention, that a network mask denotes the portion of the address which identifies the network, right? We want to identify what the network is. And also that portion that identifies our hosts, right? So as you can see, class A, class B, class C, networks have what we call default masks as shown below. You remember in the last lecture we had in ADB, we were able to convert these figures to the subnet mask given our binary conversion. Remember we said, right? With class A, let us first do the conversion very fast, right? With class A, right? We said that it has how many network bits? Class A?
8.
It has 8, meaning in our first octave, right? We are going to have all the first 8 bits converted or turned on. So we're going to have 1, 2, 3, 4, 5, 6, 7, 8, right? And the rest are going to be what? The rest are going to be zeros. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, and then 1, 2, 3, 4, 5, 6, 7, 8. So we have our first bits all turned on and our last bits all turned 0 because the host bits are 24, right? And the host bits are represented by zeros and the network bits are represented by 1s. So if we go ahead and convert this into decimal, we shall have 255.0.0.0 because all these are turned off. So it gives us an answer of 0. Are we together, guys? So that means for those who don't know how to arrive at this number of 255, remember our scale which we used, which represents the 8 bits of our network, right? Of our octave, which starts from, let's say we start from 128. We go to what number?
64.
Very good, Nabasa. We go to 64. The next one is what?
32.
32. The next one being?
16.
And?
8.
8. 4 to 1.
4 2, and 1. How we get this, for those who don't know, for those who don't, we have 2 to power 0. Here we have 2 to power 1, and 2 to power 2, and 2 to power 3, and so on and so forth until you get these numbers. Now, when we add a total of these numbers here, we get which figure? Let me just bring my calculator here real fast, right? So if I open my calculator here on my screen, and I go ahead and I add the first number, which is what? 128, right? And I go ahead and press on the add sign, and then we add another number, which is what? 64. And then we go ahead and add 32, and we add 16, and we add 8, and we add 4, and we add 2, and we finally add 1. We are going to arrive at the figure, which is what? 255. So meaning if all the bits are turned on, our figure here would be 255, and that is class A. We said class B, right, has how many network bits?
16.
They are what? 16. That means that we are going to go ahead and count 16 bits. So we count together. So this is 1, 2, 3, 4, 5, 6, 7, 8. That is the first octave. We go to the next octave. 1, 2, 3, 4, 5, 6, 7, 8. And then the host bits are how many? The host bits are 16 as well.
16.
They're represented by what? By zeros.
0.
So we shall go ahead and count 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8. Are we together? So that means that our default subnet mask for class B, after converting using this conversion method, we shall have 255. And here we shall have what?
255.
255, very good.
Zero.
Dot 0,
Zero.
dot 0.
Zero.
Very good. And then finally, our class C here, we said it has how many network bits?
24.
They are 24. So that means you are going to count 24 network bits. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8. We go to the next octave, 1, 2, 3, 4, 5, 6, 7, 8, which makes it 16. We continue with 1, 2, 3, 4, 5, 6, 7, 8. That makes it 24, because 16 plus 8, you get 24, isn't it? And the rest are zeros.
8.
So yes, 8. So 1, 2, 3, 4, 5, 6, 7, 8. So if we are to convert this, what subnet mask could we have?
255.
255. Very good.
255.
255. Very good. 255.
Dot 0.
Dot 0. And this would be our default subnet mask for class C. So we are saying that an IP address on class A network that is not subnetted would have an IP address mask similar to this, right? This one. So if you have this IP address, this would be our subnet mask. So quick question, guys. If we have this IP address, which I'm going to write on my screen, right? Of 172.16.2.4, what would be our default subnet mask for this class, for this IP address, and why?
I think the class will be C, and then the server class will be 255, 255, 255, and 0.
255.
Okay, so Patrick, thank you for that answer. Are you sure 172.16 belongs to class C? Yes, Thomas, your hand is up.
I think it belongs to class B.
Okay.
And reason being that it has 16 bits.
Very well, because 172
falls under class B, just like what Thomas has said, isn't it? So it falls under class B. Class B has how many network bits?
Yes, 16 bits.
Yes.
16 network bits.
16 network bits. So our default subnet mask would be
255, 255, 0, 0.
255, 255, 0, 0.
Very good. It would be this one, isn't it? If we had an IP address, all right, let me rub off this. If we had an IP address, or that runs from let's say 10.0.1.2, what would be our default subnet mask?
255.000.
Why is that your answer, Praise? Kawalia,
Falls under
why
class
do
A.
you think that is your answer? Please give reasons to support
It is
your
in
answer.
class. Okay, it is in class A.
Very good. So because it is class A, isn't it? And we know class A only has 8 network bits. That means that our default subnet mask will be 255.0.0.0, isn't it? So finally, if we had an IP address,
Yes.
are you together? If you had an IP address of 192.168, the one which is on my machine, .0.100, what do you think my default subnet mask would be?
It is 255.255.255.0 because it has 24 network bits and 8 host bits.
Very good. So now we're looking at the subnet mask. We have looked at the default subnet mask for our classes. Now we want to look at the subnet mask. And we have an example here of this IP address, okay, of 192.168.1.0. And how do we convert this guy into binary, isn't it? How do we convert our IP address into binary and our subnet mask, and how do we convert it into binary? For example, with my machine, all right? Let me just, we are saying that subnet masks distinguishes between the binary values that represent each network or subnetwork and those that represent each host. So by using the subnet mask, you can be able to tell that this particular bits represent the network bits and this particular bits represents the network bits, all right?
Yes.
So if we have our IP address, what was the IP address of my machine? It was 192. Dot what? 168.0.100. We can go back to our settings just for you to see and confirm, right? The IP address of my machine, which is giving me internet to conduct this class. I think I closed the settings, but I can as well as go and open them again. So let me go to the settings, open my settings, go to my network and internet, go to my Wi-Fi connection, and then go to our properties to see the IP address. This is my IP address of 192.168.0.100, isn't it? So if we wanted to, first of all, get our subnet mask, we would first of all understand the class, right, of this IP address. And you are telling me that what is the class of this IP address?
It's a class
Class
C.
C.
It is a
class
class
C.
C of this
Class
IP
C.
address. All right, so you're going to say class C of this IP address. And class C has how many network bits?
24 network bits.
24 network bits and host
8 host bits.
8
Host
host bits.
We're on the same page. Very good, just a moment. Okay, so if we want to go ahead and understand that subnet mask of this guy, right? So we need to know it is class C. Therefore, if it is class C, all the first, right? All the first network bits are turned on, meaning our default subnet mask for my computer will be what?
255.
Yes.
Dot 255.
255, very good.
Dot 255.
Dot 255.
Dot 0.
Dot 0. This is my default subnet mask. Are we together, guys? So for us to get the network address of this machine, right, to understand the network which my computer is connected to, then we need to do an operation, what we call ANDing. All right. ANDing is an operation that is used either and, or sometimes we use all. With the difference between and all is that with and, all the variables must be true. Are we together, guys? With all, any of the variable has to be true. So, but here we're going to focus on what? On ANDing, isn't it? So let me go ahead and remove these things because we don't need them now. And then come back here, all right? So if we are to continue just down below here, right? And convert our IP address into binary. So I want us to convert 192 into binary, all right? How can we do that? You want me to bring the scale or we can just now guess? We do the scale.
Let's just guess.
So it's better when you bring the scale.
It's better when we bring the scale. Okay. So our scale starts from what?
1 to 8.
1 to 8.
64.
64.
32.
32.
16.
16.
8.
8.
4.
4.
2.
2.
And 1.
And 1. Very good. So we now start from the left, right? If you're using the scale and we are dealing with a big number, we start from the left of our scale, right? And we say, is this 28 smaller than 192? Can we add it for us to be able to get 192? Is it true or is it false? It is what?
It is true. True.
True.
It is true. So meaning this one would be a what? A 1, isn't it?
Yeah. Yep.
All right. So when we add 64 to 128, what do we get? Let me get my calculator also here.
$192.
So when you get 128, right? And we go ahead and add on 64, we get 192, which is the exact figure we are looking for, isn't it? All right?
And it's true.
So it is true. So we shall need this one as well. Meaning the rest of the figures, because we have already got our 192, right? The rest of the figures will be zeros. So meaning our first octave here for 192 will be, let me go ahead and use red. For 192 will be, let me start from here. It will be 1, 1, then 3, 4, 5, 6, 7, 8. So the 192 has been taken care of. So we have our dot here, right? So we need to go ahead and also calculate 164. Are we together, guys? So let's go ahead and calculate 164. So I come back here and I say, is 28 less than 168?
Yes.
So that is true. So our first digit would be a 1, isn't it?
1.
So we have 128 already. When we add 64 to 128, shall we get 168?
No.
No.
I need your feedback, guys. Shall we get 168?
No.
We shall get 192, isn't it?
Yes.
Which we don't want. So this one is false. We shall put it as a 0.
0.
So when we add 32 on 128, which you have already, what number shall we get?
160.
One what?
60.
160. And 160 is less than 168, isn't it?
Yes.
So that is true, isn't it?
Yeah.
So we write a what?
A 1.
So you go ahead and write a 1. So when we add 16 to 160, because our total number, when we add 128 plus 132, we get 160. So when we add 16 to this number of 160, shall we get 168?
No.
So meaning this is a what?
A 0.
So we go to the next number. When we add 8 to 160, shall we get 168?
Yes.
So we get 168. So this means this is a 1.
So 1.
So we already have our number we are looking for. The rest of the numbers are what?
0.
Are zeros. So we go ahead here and write our octave being as 1, 0, 1, 0, 1, 0, 0, 0. Isn't it? We have our dot here. So we go to the 0, right? Do you think we are going to stress with the zeros? Because we just know we can't add any of these. These are all above 0, isn't it? So even adding 1 is above 0. So it makes all of these, let me rub here so that I demonstrate very well. We are looking for what number? We are looking for 0. Isn't it? We are looking for 0. So meaning all these numbers, 28 is above 0, 64 is above 0, 32 is above 0, 16, 4, 2, and 1 is above 0. So meaning all our numbers here shall be what? Shall be zeros, okay? Let me erase this. Shall be zeros. So it's going to be dot 1, 2, 3, 4, 5, 6, 7, 8. Isn't it? And then we go to the next one, which is what? We're looking for 100. I hope guys are with me. The figure we are looking for right now is 100. Let me write it here. We are looking for 100. And is 128 less than 100?
No.
So this is an automatic 0.
Yes.
Is 64 less than 100?
Yes.
So what do we write?
1.
Write 1.
We write 1. So we have, out of the 64, out of the 100 for now, we have 64, isn't it?
Yeah.
So when we add 32 to 64, right? What do we get?
96.
96. Is 96 less than 100?
Yes.
So what we write here?
1.
1, very good. So when you come to 16, we have 96 here now. When we add 16 to 96, what number do we get?
1.
It exceeds 100.
112.
Is 112 less than 100?
No.
So what number do we write here?
0.
We write a 0. Very good.
Okay,
So when you add
0.
8 or 96, do we get a number less than 100? 0. Very good. When we add 4 to 96, what do we get?
100.
And what are we looking for?
100.
So this is the number there. So meaning we can't add 2 to 100 because we already got our 100. So it is a what?
A 0.
And also this is a 0. So our last octave, right, is going to be dot what? Dot 0, dot 1, dot 1, dot 0, 0, dot 1, dot 0, 0. Isn't it? So this is how we arrive at that conversion, right? So let me go ahead and wrap this. Now, we also come to our subnet mask, right? And we want to convert our subnet mask to, to binary, isn't it? Okay.
Yes.
This was for our IP. Let me just write it here. This was for our IP, isn't it? Now we need to look down for our mask, isn't it? We said with subnet mask 255, it means all these ones are turned on, isn't it? By default, we know when you add all these numbers, we shall get what total? We shall get a total of 255, isn't it? Guys, are you still with me?
Yes, we
Yes.
are.
So that means that the first 3 octaves are going to have 1, 2, 3, 4, 5, 6, 7, 8. And the next one is going to have 1, 2, 3, 4, 5, 6, 7, 8. And the third one is also going to have 1, 2, 3, 4, 5, 6, 7, 8. Are we together? And the last one is 0. That means that all these figures are what?
As zero.
Are zeros, isn't it? So we're going to have our last one as dot what?
Dot zero.
As dot zeros. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, isn't it? They're going to be all zeros. Now, please pay attention to this important aspect, which we want to look at now, right? Let me go back to this page. Sorry. Let me go back to what? We have an important aspect, which we called what? ANDing, right? And we want to AND for us to get what we call a network address, right? To determine what our network address is, we use what we call ANDing. After determining our IP address and the binary for our IP address, and determining our MAC address and the binary for our MAC address, we go ahead and we use the method what is ANDing. And for us to return a figure which is true, remember in computing, 1 stands for what? And 0 stands for what? For false. Are we together, guys? So for us to return a figure which is true, in ANDing, we said all variables must be what? Must be true. Otherwise, if one of them is 0, then the answer is what?
False.
I repeat. When we are ANDing in computing, for example, you're working on a login system, which is going to determine if the user qualifies to access MobSafe. You have 2 variables, one being the username and the other one being the what? The password.
The password.
And we are using the AND operator. In your if function, you are going to say if, depending on the language you are using, if username and password, right, is true, then you grant permission. Isn't it? So it's the same here. So if the username is false and the password is true, the system will not allow you, right? They both have to be correct for the system to allow you to access. Are we together, guys? Okay. So we go ahead here and we start with our ANDing after understanding. So we are going to AND here. We are looking for the network address. So let me come here and just put here. We are looking for the network what? Address. Let me even change the color. So we are going to AND, right? So if you AND 1 and 1, is that equal to true?
Yes.
So meaning our first digit here would be a what?
A 1.
Excuse me.
Would be a 1. Yes, please.
I beg your pardon. Please.
With ANDing,
Yeah,
I
why
go
you
back.
are adding the ones and ones?
I go back. The first step is to convert our IP address into binary, which we have done here. All right? We have our initial IP address. Let me remove this stack around it. We have our initial IP address of 192.168. Dot what?
.0.
Dot 100. So we got its binary here, right? We went ahead and converted and got its binary there, which we have here, right? So we went ahead and got the subnet mask. Now we know that this address belongs to class C, which you guys told me very well, very boldly. And if it belongs to class C, it means it has 24 how many network bits, all right? That means the first 24 bits are all turned on. They're all ones. That's why you see we have 1, 2, 3, 4, 5, 6, 7, 8, 11, 12, 16, 13, 14, 18, 19, up to 24. All these bits are ones. They are, if we count these things here from here, 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 we are going to count up to 24 bits. Are you with me?
Yes.
sir.
So we have counted and we have converted it into, based on our default subnet mask for class C, and we have both the binary for IP and the binary for our mask, our subnet mask, isn't it? So we said we are going to use the ANDing technique for us to arrive to the network address, to know the network which our IP belongs to. And we said, well, if you're ANDing, both the variables must be equal true. And we said in computing, one represents what? True. And 0 represents what? False. And we said with ANDing, if one of these is false, it will return what? False. For it to return true, both of them must be true. All of them must be true.
Must be true. Yeah.
Are we on the same page now?
Yes.
So we come back here and we want to AND here to come up with a binary conversion of our network address, right? So we started with the first bit here on our first octave here, right? This bit here, let me just get another highlighter, right? We are looking at this octave, right? First. And firstly, we are looking at this bit here of 1. Are we together? So when we see 1 and 1, all right? Are they both turned on?
Yes.
So meaning it is a 1 which is on, isn't it?
Yes.
Aha, that is done. So we go to the next one. When we look at this one here and this one here, the second bit, right? Are they both turned on?
Yes.
So meaning we shall have what?
1.
1. Very good. We go to the third one, right? When we go to the third one, of 0 here and 0 here, right? And 1 there. Are they both turned on?
No.
One of them is false.
Yeah.
Now, if you're using ANDing and one of them is false, what do we return?
Return a 0.
We return a what?
A 0, which is false.
Which is false. Aha, we go to the fourth one. Let me change the color. So we go to the fourth one, right? So with the fourth one here, this is 0 and 1. Okay, that color doesn't look very good. But if 0 and 1, are they both turned on?
No.
So it will return what value?
0.
It will return a 0. We go to this one now. These two. We have a 0 and 1. What will it return?
A 0.
Very good. We also go here. We have a 0 and what?
And a 1.
What shall it return?
0.
And we go to this one. 0 and a 1. What will we return?
0.
And also this will return what?
0.
0. Very good. So we have our first octave done. We continue to the second octave. Let me highlight it for you again. We are on this octave here, right? Are we together? So on this octave here, we have a 1 and a 1. What will it return? A 1. Very good. We have the next bit here in our second octave. Over 0 and a 1, what would it return?
Zero.
A 0. We have our next octave here of 1 and a 1. What shall it return?
A 1.
A 1. And we have our next octave here of 0 and a 1. What shall it return?
Zero.
A 0. Our next octave here of a 1 and a 1. What shall it return?
A one.
And here,
The rest are zeros.
the rest are
Zeros.
right? Because we have zeros and ones, right? So we go to the next octave,
Yeah.
right?
Zeros.
They are all what?
Zeros.
Why?
Because it's all zero and a 1.
Okay, very good. So we have 1, 2, 3, 4, 5, 6, 7, 8. Because if these ones will return a false answer. So we go to our last octave here. Here we shall have what?
A 0.
Here, 0 here, 0 here, 0 here, 0 here, 0 here. So we have 1, 2, 3, 4, 5, 6, 7, and 8. So we have our network address in binary format. So we can go ahead and convert it now back into this. So we can have our network address written in what? In IP address format. Are we together, guys? So we can add them back. Guys, I want you to work with me. We can add them back. So we know the first bit here represent which figure?
1.
The first bit here, we have our 8 bits here of 1, 2, 3, 4, 5, 6, 7, 8. The first bit here represents what?
1 to 8.
1 to 8, right? So meaning this one represents 1 to 8. The next one represents what?
64.
So meaning to get here, we are, the next one represents 64, isn't it? So meaning this one has 2 bits on. So meaning we shall add 128 plus what? 64. We get what value?
192.
We get 192, right? When I get my calculator and add 128 plus 64, I get 192, all right? So I have dot, we go to our other octave. Are we together, guys?
Yes.
So in our octave, we have the first bit, which is what? 128.
128.
Very good. And the next one is what? The next one is 64, it is 0. The next one is 32, isn't it?
Yeah.
We are going to add 32 to that, all right? Which we shall get 160. And then the next one is 0. There's nothing there. The next one is 0. The other one is what? 8.
8.
So we shall get the others are 0. So when you add these values, we get what?
168.
168.
168.
Are we together?
Yeah.
So we go to the next ones. The next ones are all zeros. There's nothing to add, isn't it? There's nothing to add. So meaning we shall have there's no bit which is
0.0.
a 0.0. So our network address is a 0 dot what? My computer here is connected to a network of 192.168.0.0. This is my network address. And this is how we have arrived to the network address. Now, ladies and gentlemen, the trick of getting this here, if you are working with the fixed length subnet mask, which you are working on now, right? The easiest way of arriving at this number is one identifying a class, right? When you identify the class of this figure here, you get to know that this is class C, and therefore it has 24 bits. And what makes up the 24 bits? It is the first 3 octaves. Guys, are you working with me? These first 3 octaves, let me try to draw a shape here, right? These first 3 octaves forgetting where.
They are up.
Where? Up. Okay. Okay, we shall just draw. That's okay. So the first, I'll draw with my hands. These first 3 octaves, right, represent the network bits, because we know class C 24 bits. When we add all these ones here, we have added here. The first ones represent what? The network address. Are we together, guys? And these ones represent the what? The host addresses. Let me put it in. These ones represent the host addresses. So it can be .100, it can be .2, it can be .3, .20, or etc. Are we together? I am sure my phone, because it's connected to the same Wi-Fi, it could be having like 98 or whatever IP address that is assigned to it by my router. Are we together? So after knowing that the first 24 bits are network, and this is my default subnet mask, that means if you're working with a fixed length, which you're working with right now, it means that these first digits are not going to change. All right? So by default, I already have a subnet mask. I already have an IP address of 192.168.0 because I know this belongs to what? Class C, and these figures are not going to change, right? And then I know if it's a network address, it is represented, the hosts are represented by what? By 0. And have you seen how I have arrived at the same answer? But it is important for you to understand these concepts, because we are going to use these concepts later on when it comes to variable length subnet masking, which is important in today's networking, because our subnet mask, this one has a fixed length of how many bits? 24 and 8 if it is class C. It is fixed length. That means that our computers on the network, if someone wants to subnet a particular building of ADB, we need now to know if it is 2 to power 24 for us to be able to know the number of hosts that or networks that can be accommodated using that IP address. Are we together? So it is fixed length. But under normal circumstances, all right, your boss will walk to you as network engineers and asks you that, Thomas, we have a new building we have put up, and we are going to have there 15 employees. Please subnet or come up with a network that is going to support how many? 16 hosts or 18 hosts, or depending on the need. So that's when we have variable length subnet masking, which we shall look at later on. But I hope you have understood this concept very well. So moving forward, we have looked at what we call the default subnet mask. And this is the default subnet mask for our computer or for our networks of class A, class B, and class C. We have this turned on because this one has 24 bits, meaning all these first 8 digits are turned on, and this as well, and this as well, and these ones are zeros. Similarly here, the first 16 bits are all turned on. When you add 8 plus 8, you get what? You get 16. And similarly here, we only have 8 bits which are turned on, and the rest are what? Are zeros. And this is what we call the default subnet mask, depending on the class, right? So certain subnet masks are applied to address ranges by default to denote the fixed range. And remember, we are dealing with fixed, okay? Fixed length subnet masking. So when we move to the next slide of how we determine the network and host IDs, we have just gone through that process. And this is a process. I decided to put down something simple for you so that you are able to see. What we are doing here, to start with, right? We had this IP address, okay? And we're going to try it here very fast. Of 8.20.15.1, right? It is our IP address. But this IP address, the first question we ask ourselves, it belongs to what? Class.
Which class?
And which class is this?
Class A.
Class A. And we know that class A has how many network bits?
8 network bits.
There are 8 network bits, right? That means that with our default subnet mask, all the ones will be on, isn't it? And the others will be 0. And if all the ones are on, it is 2, 5, 5, isn't it? When you add all these 128, 64, 32, 16, 8, 4, 2, 1. When you add all of them, we arrive at 255. So, and then the rest would be .0.0.0. Are you together, guys? So, now to determine the network address for this particular address, for us to be able to know the network address, we have our subnet mask, which is equal to, we have our IP address here, and this is binary, and we have our subnet mask, right? Which is equal to this, and it's binary. Now, if you are going to go ahead and add this, right? Here we shall get what?
0.
We shall get
0.
a 0.
0.
Here we shall get
0.
0, 0.
0, 0.
1.
We shall get a 1.
0.
0, 0, 0.
0.
And the rest?
0, 0,
0, 0, 0, 0, 0,
Completely
0,
up
0,
to
0,
the
0,
end.
0, and 0, 0, 0, 0, 0.
0.
Now, if we are to convert this into binary, what shall we have? We know with our scale, the first digit represents what? 128, and it's off. The next one represents what? 64. This one, right? And it is 0.
32.
And this one represents what? 32, and it is off. The next one represents what? 16.
16.
And it is off. The next one
Also
represents
off.
what? 8.
8.
And it is on, right? The next one represents what? 4. And it is off. The next one represents what? 2, and it is off. And the other one represents 1, and it's off. Meaning we only have 8 there, right? So meaning our IP address would be 8 dot what?
Morning, guy. Can you join up today? I'm still in class. Today, I'm going to push for you today.
Okay, Diana, please pick up your call from somewhere else.
Jesus.
So we are saying, what is our IP address? Basing on this binary, guys, we have already got 8 from here, right? We have 8. It will be 8 dot what?
Dot 0.
0.
Dot?
Dot 0.
Yes.
Dot 0.
Dot 0. And this is our
Because of 8
network.
network bits.
Yes.
Network
And this is
bit.
why our network IP. Are you getting it? We already know that with class A, only network bits are on. So therefore, all these other numbers here represent the host, and they can change at any one given moment.
Time.
Are we together? But our address here, the 8 will not change. If it was a 9, it would also not change. Are we getting it, guys? If it was a 10, it would also not what? Change. So that is how we determine our host ID and network ID. Are we together? So when you're planning for your network, right? When you're making network address planning and you're coming up with your network, there are things you put into considerations, and we have formulas to help us achieve that, right? One, the IP address, okay? And then 2, using that IP address, you can determine the subnet mask, all right? And then using that, you can come up with what we call the network address, and then you can arrive to that. Now, what is on this screen here is what we have been doing previously, all right? We have this IP address of 192.168.1.7, right? Are we together, guys? And our subnet mask. Why do you think this is a subnet mask for this IP address?
Because it belongs in class C.
Because it belongs in class C, and therefore it has how many bits? 24?
24 network bits.
So meaning the first octave, the second octave, and the third octave, they're all turned off to make 24, right? That's why you have 255. And this is a conversion of this in IP, and this is a conversion of this in binary. when we go ahead and do the ANDing, like the ANDing we have been doing previously, we shall arrive at this IP address of 192.168.1.0. Now, have you noticed that if in class C and you know the first 3 octaves are network, have you noticed that also here, our IP address has not changed? Have you noticed? Right? So that is it. Now, when it comes to subnetting, you are ideally breaking down a big network, right, into a small and manageable network to have a robust and efficient network, right, which is going to help you utilize all the resources successfully. So when you are subnetting, you are ideally trying to understand how many devices can I have on a particular network. Or if they give you an IP address and they ask you that we need to go ahead and, you know, break this network into 2 IP addresses. So for us to determine the number of addresses, the number of host addresses, guys, please pay attention. For us to determine the number of, let's start even with a network, the number of network addresses, right? Are you with me? For us to determine the number of network addresses, we use the network bits, right? The network bits to determine the number of network addresses that can be available when you're subnetting. If we follow 1 bit here and we had 1 bit here of networks, right? And it is 1, 1, 1, 1, and there's a 1 here. For us to know the number of networks that can be there, in this case, it is going to be 2 to power what? To power 1, all right? And 2 to power 1 is equal to how many?
2.
So we shall have 2 networks, right? So that means under normal circumstances, class C, right? It has 2 to power 0 under normal circumstances, right? And it is 1 big network. 1 big network to determine the number of host addresses, how many hosts can be on this network, right? We are going to go on this 1 network we have of class C. We are going to go ahead and say 2 to power the number of host bits. Are we getting it? To get the number of hosts on that network. So how many host bits do we have in class C? Guys?
8.
There are how many?
8 host bits.
There are 8 host bits. So if you go ahead and 2 to power 8, what shall we get? We shall get 256. But it is important to note, like I told you earlier on, guys, right? That all these addresses cannot be used. There are always 2 addresses, which we do what? There are 2 addresses we do what?
Use.
We reserve, right? We reserve which address? The network address and the what?
And the broadcast.
And the broadcast address. That's why to get the number of valid hosts which can be connected on this 1 network, right? Our formula would now be to power 2 to power number of host bits minus 2. Are we getting it, guys? So that if we go ahead and we get 256 addresses on our network, but we are going to subtract 2, and we can only assign our host addresses 254 addresses. Are you with me, guys? Very, very important.
No.
Right? If we have 256, our formula to get the number of addresses, host addresses, right? We are saying it is 2 to power number of host bits. These are the host bits. They are 8. 1, 2, 3, 4, 5, 6, 7, 8. Isn't it? 8 bits for network, for class C, right? And for us to get the number of valid addresses, we know that 2 to power n is just going to give us all the addresses available on this network. Are we together, guys? And it's going to give us the number of 2 to the power 8, which is equal to 2 what? 56. But if you want to get the number of valid hosts, the number of valid addresses we can give to our hosts, right? Remember, there are 2 addresses we don't assign hosts on our network. I told you this at the beginning, and I'll emphasize once again. The first one being the network address, and the other one being the what?
The broadcast address.
Broadcast address. That's why our formula now to get the number of valid hosts on the network is 2 to power of number of host bits minus what? Minus 2. Are we together, guys? So if we are to do this, we shall get 2 to the power 8, right? Which is equal to what? 256 minus those 2 addresses of the network and broadcast, and meaning we shall have a luxury of assigning 254 addresses to all the computers on our network. Are we together, guys?
Yes.
Okay. So now we have this scenario here, and we are going to determine now. Quick questions. We have our IP address here, right? Are we on the same page? Very common scenario. You have been hired. Airtel has taken you on, and we have that range, right, of address. And I want you to now help us understand how many, or to determine the network of the given IP address, right? And the number of actual and valid host addresses, right? So I want you to go ahead in your free time to calculate that, right? But before we do that, we can determine the number of actual and valid host addresses. We know, before I go ahead, that this is what class?
Class B.
It has how many network bits?
16.
There are 16. And how many host bits?
16.
There are 16. Now, for us to determine the number of host addresses, the actual host addresses, our formula is 2 to the power what?
N.
And N stands for what?
For the number of hosts.
Very good. The number of host bits. And in this case, our number of host bits is what?
16.
So 16 power, 2 power by 16, we get what?
65,000. 536.
Minus 2.
65,500. So 2, very good. 2 to power 16, we get 65,000, right? 536. So our answer would be 65,500 and what? 36 actual host addresses, right? These are actual. But if they wanted to know the valid now, right? Our formula would be what?
2 to the power n minus 2.
Minus 2, very good. So if we come here, it will be 2 to power 16 minus 2, which will give us 65536 minus 2, which will be equal to 65553 what? 34. And this is the number of valid addresses. Now, in the interest of time, we are not going to go ahead and calculate the network IP address. But using my shortcut, I can easily now determine the network IP address, right? I know when you go ahead and calculate, this is what you will arrive at, right? You'll get 172.16.0.0, right? You know why? Who can try and guess why this is our network address? If you calculated it now, you'd arrive at this. Who can guess why that is our network address? You even have a clue here on our subnet mask.
So class B has 16 network bits and 16 host bits. And each octet will have 8 network bits.
Okay.
So 172 will have the 8 and dot 16 also have 8, combining, making 16 network bits. Then the host bits will be 16 as well.
Yes, so that means these first 2 octaves represent the network bits. Are we together? So when we meet again next week, it is important that I have introduced you to that concept